Okay, so now let's next to this is sprinkler irrigation design. So as we already talked that there are four types of sprinklers. So one is a portable system, second is semi-portable system, third is a set move or portable irrigation system, or third one is continuous move system. So portable system, it has portable miniature, okay, portable main lines, sub main lines and lateral, and portable pumping unit. All are movable. Where semi-portable system is similar to portable system except location of water source and pumping plant is fixed. So in semi-portable system, what is the main difference? So water source and pumping plant is fixed, while other all the system like main, sub-main, laterals are movable. Set more portable irrigation system, in that case movable one set position to another, and continuous moving system. So it has a laterals and sprinkler that remain connected to main and move continuously as water is applied. Then specifically now, so yeah, and the angle, nozzle angle is varies from 90 degree to 360-degree, and the low pressure, it works between low pressure as up to 1 kg per centimeter square, and its application rate is varies from 1.25 to 5 centimeter per hour. Okay, so this is the in case of drip irrigation, while in sprinkler irrigation system it works in between 2 to 4 kg per centimeter square, and its application rate is varies from 4 to 20 centimeters per hour. Now we have also then talk about components of sprinkler irrigation system. So where there are various components like starting from pumping unit, then we have main line, sub main line, various kind of filtration system on that, then fertigation system. Combining all this, we can design sprinkler irrigation system. Now let's focus on hydraulic design part of the sprinkler irrigation system. So primary factors that control the operation of sprinkler is operating pressure and nozzle geometry. So nozzle geometry depends on opening size of nozzle, shape and angle of the nozzle, and sprinkler performance parameters that we can plan is there are total six parameters. So first one is the sprinkler discharge, then uh, distance of throw, then distribution pattern, droplet size, application rate, and uniformity coefficient. So discharge through the sprinkler nozzle is given by this formula: Q is equal to C A under 2GH. Then water spread area of sprinkler A is equal to pi r square. Then radius of the weighted area of sprinkler is given by R is equal to 1.35 under root DH. Breakup by jet index is given by PD is equal to H by 10Q raised to 0.4. Then uniformity application, Cu is given by 100 times 1 minus summation of x divided to m to n, and pattern efficiency is given by minimum depth by average depth into 100. So all these are the important formula while designing the sprinkler irrigation system. Then capacity of sprinkler irrigation is given by Q. So it is simple area, velocity into area or application rate into the area. So that will give us total capacity of sprinkler irrigation system. So these are all the formulas related to head loss, then required irrigation time for sprinkler irrigation system. Right. So this will also will learn through numerical examples. Then we have focused on drip irrigation system. So drip irrigation system, so there are two major components. So One is a control head and second one is a distribution network. So control head, this includes the pump or overhead tank, fertilizer or chemical application device and filters. So there are the control heads that they are installed near the water source, right, to control the or to clean the water, because the emitter that we have in at the end of drip system that have a very small diameter and that required clean water, so there is a no clogging, right. For that we have a various kind of filtration system, so that comes under control head. Then we have a fertigation system. So whenever you want to provide irrigation with fertigation or fertilizer, then you required fertigation system like venturi system. Okay, so in that case, uh, fertigation system, venturi injection is the most common fertigation system, so that required. Then comes to the performance evaluation of drip irrigation system. So in that, there are three main characteristics that we need to focus on. So first one is manufacturing characteristics, second one is operational characteristics, and third one is hydraulic characteristics. So manufacturing characteristics, uh, that basically compute the coefficient of variation of emitters discharge measured at 1 kg per centimeter square. Then operational characteristics that measures the uniformity of water application through drip emitters. And then hydraulic characteristics compute discharge. Okay, so this is the entire drip irrigation system that are shown here. Okay, so this is the major water source. Then this water is coming to at farm level storage. Then we have a pump here that extract the pump. Then after pump we have various kind of valves, non-return valve, bypass valve. Then the first water comes into the filtration system, that is sand separator, so that ultimately remove large particle. That we have hydrocyclone filter. Then screen filter at the end we have. Then we are also having a fertigation system arrangement, and then water is moving to main line, sub main line, laterals, and then this lateral we have a drippers. Okay, at each crop. Uh, so that dripper emits discharge, design discharge, right, as given in uh, that design parameter or water requirement of particular crop. Then in installation of drip irrigation system, so in that also we have a two kind of units. So one is a head control units and second is water distribution network. So head control unit basically have the system like installation of filters, installation of fertigation equipment, and in distribution network we have mains, submains, laterals, emitters, etc. And then come to the operation of drip irrigation system. So this is the field are showing. Okay, so these are the field installation of submain mains line. Then this is the pumping unit, filtration unit, and this are the farmers that are working on the field. Then in continue with this, there are certain maintenance criteria for filtration system, because if it is not working or even working, we require certain maintenance guidelines. We need to follow that. So filter cleaning. So filter is the heart of drip irrigation system, and its failure will lead to the clogging of the entire system. And there are we have total three types of main filters. So first one is the hydrocyclone filter, sand filter, and screen filter. And maintenance of fertigation equipment. So venturi injector should be operated with clean water for 10 to 15 minutes to prevent clogging, and maintenance of main and sub-main lines. So for that we need to do flush valve. We need to operate flush valve to seal escape and removing caps from laterals. Then in chemical treatment of mains and sub-main lines, so with use of hydrochloric acid or chlorine, so clogging and plugging is usually removed by this kind of chemical treatment. And maintenance of lateral pipes and drip emitters. So for that similar kind of treatments are required. And this fertigation unit, in that we have three main units. So that is a venture injector, uh, fertilizer tank, and injection system. And this already we know that control head, drip irrigation is designed by control head unit and distribution network. So in this, generally water collecting and pumping. So water is collected from farm pond and then pumped into the main line using the pump. Right. So water is collected in the farm ponds. That is, we have to design, and then through pump it delivers to the main line and sub main line. And filtration. So filtration is water is moved through the main line. It passes through a sand separator and screen filter, which removes the impurity to prevent clogging of the emitters. And then it's come to the distribution network where main line and sub main lines are laid. And fertilizers also we can add in between based on plant requirement. Then we have also talked about design step that we need to focus, that we need to must keep in mind. So first is that like inventory of resources and data collection. First is a fundamental step in any uh, system design, and then computation of peak crop water requirement and capacity of drip irrigation system. And then we need to decide the appropriate layout of drip irrigation system based on farm size and farm shape. Then we need to select number of emitters, again based on crop water requirement, crop root zone depth, and how it's going to spread during its growth stage. Then hydraulic design of system. In that we need to decide discharge, then length, everything, and then pump horsepower requirement. So all this combining, we can design this drip irrigation system very efficiently. And these are the design steps. So first one is to estimate the water requirement. So it is basically crop and field water sources based on that. And then we need to select the emitter and irrigation time. It is selected based on the uh, factors like crop water requirement of specific crop that we are planning to grow in our field. Then this determination of number of manifolds, size of lateral, size of submain and mainline, filter selection, determining the horsepower of the pump, and final design criteria like adding certain error that might occur. So we take 10 to 15% more design consideration to consider extreme situation. So these are all the formulas that highlighted here for drip irrigation system design. I'm not going into detail. Then fertigation system, as I already highlighted. So fertigation system have three main system: venture injector, fertilizer tank, and injection system. Among this, venture injector is the common one and most commonly used in the field. So it basically help us to add fertilizer with irrigation water. Then types of and selection of filters. So there are five types of filter: gravity filter, sand filter, centrifugal filter, serene filter, and disc or ring filter. So gravity filter is generally utilize the force of gravity to separate the heavier particles from water. And these are typically simple and cost effective, but not remove finer particles. So gravity filter basically able to remove the larger particles. Then we have a sand filter. So sand filter, so in that water is passed through the bed of sand, so that traps and removes the suspended solids. So it is more like a sand filter. So that sand filters have the such condition, so like that traps the finer material. Okay, and sand filters are effective in removing both inorganic and inorganic particles, are commonly used in irrigation system. Then centrifugal filters, so it uses the centrifugal force to separate the particle based on centrifugal force, so that works based on the size and density of particle. And this particle are particularly effective in removing larger particles like sand and grit. Okay, and then we have a screen filter. So screen filter, in that water passes through screen. So that screen have a mesh kind of structure, and that mesh generally uh, uh, trap the particle that are not of interest, and then we have a disk or ring filter. So again, it comprises of stack groove of disk or rings that creates the shortest path of water, and particles are trapped within grooves, effectively filtering the water. Then this is the uh, fundamental or design criteria that we need to focus on. So in that, initial data collection and field survey is the fundamental requirement of the any irrigation system design. Then we need to calculate the crop water requirement. That is third step, and that detailed calculation we have already talked in week number 2 and 3. Then determination of water supply requirement. So it is like crop water requirement into the area, and then emitter selection and emitter discharge calculation. So that is given by this formula. Okay, so we'll solve this kind of problems in this session. So I'm not going into detail, and already we have learned about this. So I hope you are already watched that lecture. Then determine the weighted area perimeter, determine calculate the number of emitters required per plant, then determine irrigation time and evaluate the performance or emission uniformity of the system. Finally, we need to design the system layout and pipeline design, and then we need to check the pressure and flow distribution, and based on that we can plan the design. Now let's move on to the question and answer session. So so let's start with question number 1. So before that, let's take 5 to 10 minutes break here, and then we'll continue. Okay, I'm not feeling well, so I'm not able to talk too much. Okay, so let's resume our session. So let's now focus on question and answer session. So it is more helpful for you, right? You need to solve the questions during your examination or NPTEL examination. So they also have similar pattern like MCQ question and numerical questions. So let's focus on this. So question number one, water application rate of a sprinkler is affected by wind speed, temperature, infiltration capacity of a crop type. So we know that correct answer is option C. That is infiltration capacity of soil. So this is the fundamental properties that affect the water application rate of uh, sprinkler, right? Because the rate at which the soil can absorb water affects how quickly water applied via sprinkler can penetrate into the soil surface. Sorry, right. So correct answer is option C. Question number two: the main and sub-main sprinkler system are installed permanent while laterals are portable and moved by hand or mechanically. So that kind of system is known as a semi-solid, semi-permanent system, fully portable system, or both A and B. So we know that the correct answer is option B, semi-permanent system. So in semi-permanent system, it offers a mixed stability and flexibility with main and sub-main pipes are typically buried and laterals can be moved. Okay, so correct answer is that one, option B. Question 3. The flow rate of micro sprinkler having an orifice control ammeter is influenced by orifice position, orifice diameter, orifice length, or orifice height. We know that orifice diameter is the most critical or important factor that affect the flow rate, and larger the diameter of the orifice, higher the flow rate, as smooth water can pass through the larger opening. Conversely, small orifice diameter results in a smaller flow rate because of less water passed through given pressure. While other is also important factor, but they are not impacting as high much as orifice diameter. Right. So correct answer is option B. Question number 4. In micro irrigation, drip emitters are usually made up of HDPE, PVC, polypropylene, or LDPE. So we know that generally drip emitters. So that emitters is consist of polypropylene, right? So these are the structure of polypropylene, right? Uh, Polypropylene and polyethylene, while other components like main line that consist of HDP or HDP or PVC. So main and sub main are consist of that, but have a different diameter and different pressure range. While ball valve, then we have flush valve and laterals that consist of LDP or LLDP, and emission device like emitters consist of polypropylene or polyethylene. Correct answer is option C. What is the main reason for difference between drying and wetting curves of soil characteristic curve? So we know that soil moisture characteristic curve is the curve between soil moisture and soil water potential. So it basically gives the difference between like sorption and desorption curve. So when soil is wet and when we remove the water by applying some pressure into that, so that causes removal of moisture. So this is removal of moisture, and when we again reweight or weight that dried soil, so that both path of soil moisture gaining and losing have a different path. So the difference in this path is caused the hysteresis effect, and this hysteresis effect is basically due to the Capillary hysteresis caused by different pathways of water movement. Okay, the correct answer is option B. Question number 6. Identify from the following characteristics of micro irrigation which one is most correct. So, uh, micro irrigation system, so it have a low water application rate, it is correct. Frequent water applications, yeah, it is applying frequently, water we are applying frequently in this kind of irrigation system. Application of water in root zone, that is also higher, and required high pressure to operate, so it is incorrect answer. Correct answer is option D. So these are the other micro irrigation characteristics, so please go through this. Okay, now next question, question number 7. So we know that these are the different type of emitters and its flow characteristics. So long path emitters are generally having a micro tube kind of structure. Then bottom emitters have on that is also known as online emitters. Then line source emitters are related to the close. Generally, we are using for close growing crops. And pressure compensating emitters that we are using for undulating or hilly terrain, right? Because its ability to compensate the pressure difference. And orifice flow Tutus path emitters are generally are having a fully turbulent flow kind of characteristic. So these are the pressure head discharge relationship of emitters. So it is a relationship between discharge and head. So this discharge also known as the flow rate. So H is the operating pressure head, CD is the coefficient of discharge, and X is the exponent. So in case of pressure compensating emitter, right? So these are the pressure in compensating emitters, also known as the variable flow path emitters. So in that case, this X value is minimum. Minimum means the discharge is not directly impacted by operating pressure head. Correct. While as you go down towards laminar flow condition, okay, in that case, what is happening? This exponent X is uh, having increasing towards 1. It means there is a higher impact of this H, operating pressure H. Okay, so these are the main fundamental to design or selection of any drip emitter based on the operating pressure. Now question number 8. So water saving of the tune of Kali dash is possible in sprinkler system. So in sprinkler system, we know that total 30 to 50% of saving is possible. The correct answer is option A. Question 9. Water is applied slowly below the soil, right? Below the soil using line emitters in. So it is subsurface irrigation. Okay, subsurface drip irrigation system. So correct answer is option C. Question number 10. What is the recommended maintenance practice of hydrocyclone filter? So hydrocyclone filter, so we know that it requires daily operating opening of backwashing valve for cleaning the dirt and inside the chamber. Apart from that, it also require hydrocyclone filter should be installed before sand and screen filter, and for cleaning the dirt inside the flow chamber, open backwashing valve daily is a fundamental requirement. And flush the chamber by opening flush valve or cap through cleaning. So correct answer is option B. Okay. Question number 12. How frequently should the sand filter be backwashed during operation? So we know that sand filter, so it should be backwashed every day for 5 minutes to remove silt and other dirt accumulated during the previous day's irrigation. And once a week, while backwashing or backwater should be allowed to pass through the lid instead of backwash valve. And sand in a filter bed should be stirred up to the filter candles without damaging them. In this, correct answer is option C. Right. So daily 5 minutes to remove silt and dirt is required to clean the sand filter. What is the recommended sprinkler spacing for micro sprinkler to ensure high uniformity of water application? And what is the common range of lateral spacing? So a recommended spacing is 5 meter by 5 meter. Okay. While common recommended spacing was sprinkler long laterals between laterals typically from 5 to 7 meter. So correct answer is so 5 meter by 5 meter and this 5 meter by 6 meter. Right, because other are 4, here is 6 to 8, here is 7, 8. The correct answer is option B. Then question number next question, that is on just a second. Okay. Next question. When designing a submain line in an irrigation system, which of the following statement is correct? So we know that submain line is indeed in design to allow approximate same energy loss as the lateral line for several laterals, and the submain line is combined. And this ensures a uniform pressure distribution and efficient operation of irrigation system. Energy loss in submain line is directly related to its length, and longer submain line typically have a higher energy loss due to the friction and other factors. So Kaler and Carmelli recommended that lateral energy should be 55%, while submain energy loss should be 45%. Okay. And final, even though PVC pipes are typically uh, smooth, the hydraulic characteristics of submain line, including factors like friction loss, must still be considered to ensure proper design and functionally of irrigation system. The correct answer is option A. In the design of drip irrigation system, what is the maximum allowable pressure difference between head end and the end of lateral? So pressure difference allowed between maximum allowable pressure difference between head end and tail end of the lateral in drip irrigation system is 10%. So right, so it is correct. While if they ask about velocity, so velocity is 20%. Next question: which of the following characteristics ensures the highest uniformity when selecting emitters for a drip system? Hydraulic, operational, manufacturing, or none of the above characteristics? Okay, so we know that hydraulic characteristics uh, ensures the highest uniformity when selecting emitters from drip irrigation system. So correct answer is option A, right? Because uh, laminar flow emitter regulates the water flow by dissipating energy via friction against walls of water passage, while turbulent flow emitters regulate water by dissipating energy in friction against walls of water passage and also between particles themselves during their turbulent movements. Then apart from that, we have two other characteristics: operational characteristics and manufacturing characteristics. So they are calculated by given formulas. Question number 17. So we need to match this with this. So Kawasa formula, we know that Kawasa formula that we are using for dealing with the eff- efficiency of the rotating head sprinkler in distributing water. And Tanda is recognized for creating index used to evaluate the drop of backlet, drop breakup in a sprinkler. It is related to the option D. Then pressure intensity. So pressure intensity describes the rate at which the water is applied to field sprinkler. Okay, option A. And bubbler. So bubbler is a low pressure system and high efficiency irrigation methods to deliver water directly to the base of plants. And Burt or Keller are known for their contribution to development of models or theory in irrigation engineering, such as mean Nielsen model, which may be applied to optimize sprinkler aid design for uniform water distribution. So these are the correct answers. Question number 18. What is the primary function of energy dissipated in point source tripometer? So these are the repetitive questions. So we have already solved this. So not going into detail. Then the correct answer for this is option B. Right. So this is the drip emitters. Okay. Let's see it clearly. This is the emitters. Okay. So emitters have a different arrangement to distribution of water energy via different design. Then which type of dripper is most suitable for use in uneven sloping terrain? So we know that pressure compensating drip emitter, so that not impacted by operating pressure, right? So we know that Q is equal to CD H raised to X. So exponent emitter exponent X is here 0. It means this H is constant. So discharge is not impacted by operating pressure. Correct answer is option C. Which of the following is characteristics of non-pressure compensating drippers? So non-pressure compensating drippers do not have a mechanism to adjust for pressure variation, so the discharge rate can be changed with fluctuation in operating pressure. And these drippers are simpler, cheaper, and often used where such variations are acceptable. Uh, so the correct answer is option C. The discharge tends to very low with operating pressure. Next question. Which of the following statement is correctly differentiated between surface irrigation and subsurface drip irrigation? So surface irrigation uh, applies water on or above the soil surface and is commonly used for perennial crop and row crop. Subsurface drip irrigation system applies water below the soil surface and it reduces the interference with cultivation and possibly expanding system operational life. So discharge rates for both systems are generally less than 12 liter per hour. Okay, so correct answer is option B. That surface drip irrigation system is primarily used for perennial or annual crop, while subsurface drip irrigation system uh, have a less interface with the cultivation and potentially have a longer operational life. Correct answer is option B. That is given in option B. Now let's solve the numerical question. So before that, let's take 5 minute break here. Then we'll again continue our session. Okay, let's resume our session. So, first question is a sprinkler irrigation system has a sprinkler spacing of 20 meter along the main and 20 meter along the laterals. That is used to irrigate the crop grown on a coarse sandy soil with land slope of 2%. The maximum allowable application rate is 3.75 centimeter per hour and total 25 sprinkler are used to irrigate the field. The capacity of sprinkler irrigation system that we need to identify. So we know that SL, that is spacing between lateral, spacing between mains, are given as 20 meter. Irrigation application rate is 3.75 centimeter per hour and it's equivalent to 37.5 mm per hour, and number of sprinkler that are used for irrigation is 25. So the required discharge from individual sprinkler is Q is equal to SL into SM into I divided by 3600. So this SL and SM is in meter, I application rate is in mm per hour, and divided by 3600, that converts into seconds. So correct. So Q is equal to, for individual sprinkler is 4.17 liter per second. Now for system capacity we need to multiply it by 25 sprinklers. So 25 into 4.17 is equal to 104.25 liter per second. Question number 2. A sprinkler irrigation system operates daily in 2 shifts to meet the peak crop water required demand. Sprinkler system operates 8 hours in each shift, and a 12 hectare area is irrigated in each irrigation cycle of 7 days. Gross depth of irrigation is 100 mm. Capacity of sprinkler irrigation system in liter per second that we need to identify. Here A is given as 12 hectare, D is equal to 100 mm is equal to 0.1 meter, and NS is equal to 2, I is 7 days and T is 8 hours. So capacity of sprinkler is given by Q is equal to 10 times A into D by INS T. Let's put all this in the given equation, and our final answer is 29.76 liter per second. Third question. A single nozzle sprinkler of 4.5 mm size operates at 3 kg per centimeter square pressure. Coefficient of discharge for nozzle is 0.92. The discharge from sprinkler nozzle in liter per second is dash. So we know that it is given by Kawasa formula, that is CD A under 2GH. So A is equal to pi by 4 D square. So D is given as 4.5 mm. Let's convert it into the meter. So pi by 4, 4.5 10 to the power minus 3, that square is equal to 1.59 into 10 to the power minus 5 meter square. Now let's put into the above equation of Q. So CD is given as 0.92, A that we have identified, and 2 times gravity, that is 9.81, and H is given as 3.5 kg per centimeter square. Then the final answer is 0.38 liter per second. Why we took here 35? Because we know that once we convert this kg per centimeter square into meter, so it comes as number, we need to multiply it by 10. Okay, because 1 kg per centimeter square pressure is equivalent to 10 meter. So final answer is this 0.38 liter per second. Next question. A sprinkler irrigation system consists of 200 meter long lateral lines at 20 meter spacing. The field is square having a 4 hectare area and required depth of irrigation is 8 cm. Based on the infiltration capacity of soil, the desired water application rate is 1.25 cm per hour. Sprinkler system operates daily 8 hours, and the time required to move each 100 meter long sprinkler lateral line is 45 minutes. The number of days required to complete one irrigation is dash. So irrigation requirement is given as 8 cm. Application rate is given as 1.25 cm per hour. Area is equal to 4 hectare, and field that we need to convert to meter square. So 4 into 10 to the power 4 meter square. and T is given as 8 hour. Now irrigation time, so simply irrigation requirement 8 divided by 1.25, okay, that is the application rate. So total time is 6.4 hour required. So time required to moving lateral is 45 minutes. So total time per setting is 6.4 into 7.75 hour. So it is 7.15 hour. Now field is square and having area of 4 into 10 to the power 4 meter square. So it is almost equal to 200 by 200 meter. Therefore total length of field is 200 meter, and the entire length of 200 meter is covered by 200 meter laterals. Therefore number of moves required is equal to 200 divided by 20, right? That is total 10 moves. Now total timing required is equal to 10 moves into 7.15 divided by 8. So that is equivalent to 8.94, and it equals to 9 days. Now let's I'm not going into the detail of this each question due to again my health issue, and I have throat infection, so I'm not able to talk too much. So thank you for your understanding, and I request you to go through the prepared questions here. Okay, so these are the based on the given formulas only, or whatever concept we have learned during this chapter or week number 5. So please go through this, and if you have any query you can directly ask me during next session. So or you can also write down in between to my email ID. So these are the questions, very simple ones. So you once you'll go with step by step given information, then definitely will able to solve this. So with this I'm ending this session here. So before that, let me quickly recap that what we have covered. So in this lecture basically we have covered about uh, irrigation system design. So basically in this we have focused on drip and sprinkler irrigation system. So we have started sprinkler irrigation system, then we have talked about types of sprinkler irrigation system, then how we can design the sprinkler irrigation system, what are the hydraulic characteristics, operational characteristics or manufacturing characteristics that we need to make sure during sprinkler irrigation system. And similarly pattern we have followed during drip irrigation system design. So that also like what type of drip irrigation system we have, what are how we can compute the water requirement, and then so that basically comes under design characteristics. So in that also we have operational characteristics, manufacturing characteristics, then design characteristics. Criteria generally involves different kind of emitters we need to select based on the crop water requirement or elevation or pressure head, operating pressure head that we have observed or we can calculate it, right? So based on that we can select the emitters, and then how we can design the drip irrigation system considering the field size and shape, that also we need to take care of. Then we finally solved certain multiple choice question and numerical questions, and then I gave you certain example to solve by yourself by choosing this slide. So I am not going into the detail of that. So last 4 to 5 questions please solve to yourself, and let me know if you have any query by next week so we can plan and discuss it. So with this, thank you so much for joining today's sessions, and I hope you will enjoy this learning sessions. And I hope you will continue this session and inspiring me through joining this session. So scan this QR code or click into this link to go to my YouTube channels and learn about previous week content, and also you can access the lecture material here by clicking this link. So I have uploaded all the session lecture material in the PDF format in this Google Drive folder. So okay, so thank you so much for joining today's session, and if you have any query you can write down, okay, to my email ID. So I am ending this session here. Thank you so much.